Hello, Algebra 1. Today we are looking at our Unit 7, Lesson 1, which is finding unknown inputs. So example 1, a mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform 20 feet above the ground with an initial velocity of 92 feet per second. It is represented by the function ht, negative 16t squared plus 92t plus 20. Here is a graph representing the function. For each question, be prepared to explain your reasoning. So number 1, what is the height of the potato 1 second after launch? So it would be approximately 96 feet, because we're looking right here. Or if you plug in your 1 for your t, you would get that answer also. Number 2, 8 seconds after launch, will the potato still be in the air? So that would be no, and we can see that on the graph too, because it lands way before the 8. Number 3, will the potato reach 120 feet? If so, when will it happen? So yes, the potato's height will be 120 feet at 2 times, approximately 1.5 seconds and 4.3 seconds. And number 4, when will the potato hit the ground? And that is after approximately 6 seconds. Okay, we are skipping example 2. You can read through it yourself and try and figure it out if you'd like to. But here's example 3. Here's a diagram that shows the picture with a frame that is the same thickness all the way around. The picture is 7 inches by 4 inches, and the frame is created from 10 square inches of framing material. So number 1, write an equation to represent the relationship between the measurements of the picture and of the frame and the area of the framed picture. So let's label the picture. So the picture is 7 by 4 inches, and the frame is created from 10 square inches. So if we do 7 plus 2x times 4 plus 2x equals 38. Or we can do 4x squared plus 22x plus 28 equals 38. Number 2, what would a solution to this equation mean in this situation? A solution would represent the thickness of the frame when all the framing material is used. Okay, we are going to skip example 2 because that one is very hard to do over online. So here's number 3. Here's a diagram that shows the picture with a frame that is the same thickness all the way around. The picture is 7 inches by 4 inches, which I have already labeled, and the frame is created from 10 square inches of framing material in the form of a rectangle measuring 4 inches by 2.5 inches. So number 1, write an equation to represent the relationship between the measurements of the picture and of the frame and the area of the framed picture. So we would write this as 7 plus 2x, because if we're looking at just the picture, that is 7. But then we're going to add the frame also, and this is going to be our x. And so we're adding 2 x's to the 7, so it would be 7 plus 2x. And then if we are looking at our height, this right here is 4, but again we need to add x's again to include the frame. So that would be 4 plus 2x. And then to get our total area, we would do our 7 times our 4, which is our our picture, and then 4 times 2.5, and that would give us our frame, and that equals 38. And then number 2, what would a solution to this equation mean in this situation? A solution would represent the thickness of the frame when all the framing material is used. Okay, now we're going to look at lesson 2, which is when and why do we write quadratic equations? So example 1, the expression 12t plus 250 represents the cost to purchase tickets for a play where t is the number of tickets. Number 1, a family paid $62.50 for tickets. How many tickets were bought? So one way to do this would be to subtract 250 from 62.50, and that'll give us $60. And if 12t equals 60, then t has to equal 5, because you would divide each side by 12, and 60 divided by 12 is 5. So they bought 5 tickets. Okay, number 2, a teacher paid $278.50 for tickets for her students. How many were bought? So again, subtract 250 from that, and that will give us $276. And then if 12t equals 276, and we divide that out, then t would have to equal 23 tickets. Looking at example 2, the other day you saw an equation that defines the height of a potato as a function of time after it was launched from a mechanical device. Here is a different function modeling the height of a potato in feet t seconds after being fired from a different device. So what equation would we solve to find the time at which the potato hits the ground? So here we would do negative 16t squared plus 80t plus 64 equals 0, because we want to know when it hits the ground. And then number 2, use any method except graphing to find a solution to this equation. So we would write out our equation equal to 0, like we did right here, and then subtract 64 from each side to get rid of this variable. And then it'll give us negative 16t squared plus 80t equals negative 64. And then if we divide each side or each variable by negative 16, that gets rid of that one. This would equal a 5, and then this would equal 4. And then we would get t squared minus 5t equals 4. And then here, the easiest way to do it would be to graph it, but since we cannot graph it, one way to do it would be to plug in different numbers for t. And then if we plug in 5, we get 64, and if we plug in 6, we get negative 32. And so if we had to guess, we would do 5.7, because that is the closest number where we would get 0.